Hi everyone, my name is Megan McGovern, and today I will be addressing the scientific misconception of acceleration. In our everyday lives, we use the term acceleration to mean speed up or get faster. For example, Usain Bolt accelerated to the finish line, or the NASCAR drivers accelerated around the track. While this definition is not incorrect, it is not a complete definition of what acceleration truly means. In thinking about acceleration, it's helpful to use the image of a car. The gas pedal naturally comes to mind when I think of acceleration because our gas pedal makes our car go faster. However, the brake can also be seen as an accelerator because acceleration is any change in speed, whether the object is getting faster or slower. Since our brake enables our car to slow down, it also acts as an accelerator. Additionally, acceleration can mean a change in direction. Therefore, our steering wheel can be seen as an accelerator because it enables our car to turn or change directions. A complete definition of acceleration would be any change in speed and/or change in direction of an object. To address the misconception of acceleration, this demonstration will need an Ozobot marker, Ozobot, blank paper, an Ozobot code sheet, and an iPad. The first challenge in this demonstration is to ask students to draw a code to make the Ozobot accelerate. As we mentioned before, the misconception is that acceleration means getting faster. So it's important to expect that most students will use a code that makes their Ozobot go faster. Ask students to explain why they chose their code to demonstrate acceleration. Next, ask students to draw a code to make the Ozobot slow down. Then ask students if this code shows acceleration. Based on the misconception, it's likely that most students will say no, this code does not show acceleration because the Ozobot is getting slower. At this point, it's important to expand our students' definitions to realize that any change in speed, such as slowing down, is acceleration. Lastly, ask students to draw a code to make the Ozobot change direction. In this example, the Ozobot is doing a U-turn. Again, ask the question, is the Ozobot showing acceleration? Students are again likely to say no, because so far we have only expanded their definition to include changes in speed, whether that be faster or slower as in the second challenge. Now it's time to expand their definitions further to include that acceleration may also be a change in direction. Even though the Ozobot remained at a constant speed, it did change direction, therefore it accelerated. At this point, it would be useful to have students go back to Challenge 1, which was to demonstrate how the Ozobot demonstrates acceleration. They can then make revisions and changes to their original codes and record their Ozobot onto Seesaw. Seesaw is a digital portfolio that allows students to reflect on their work. This would be a great way to check for understanding and plan future instruction on acceleration. Thank you for listening.